exact procedure we will see now, how to isolate the caffeine from tea leaves. So this is our procedure, and with the help of this procedure we are going to perform our experiment, isolation of caffeine from tea leaves. So first of all, you have to take 25 gram of powdered leaves. Okay, so you can use any kind of tea powder, like any red label society, anything, whatever you are getting from the market, you can use that one. So to boil 25 gram of powdered leaves into 50 ml of water in a beaker. The aqueous solution is filtered. We have to filter that one like tea, what we are making for tea. No, we do boil tea powder in water. So same thing we have to do, filter that one. Again in that tea powder, in tea leaves, tea powder, whatever extract, whatever solid remain in that our beaker, we have to add again water. Again we have to boil it for 50 to 20 minutes, and again we have to collect that filtrate after filtration. So this filtrate we have to combine, and we have to add to this filtrate the lead acetate solution. So 10% lead acetate solution we are going to add to this filtrate, and until no more precipitate. So after addition of lead acetate, we can see there is a formation of precipitate. Okay, the mixture is filtered while hot. Okay, so what is the precipitate? Which content is getting precipitate out? So tannin, we have seen tannin is present, which has phenolic hydroxyl group, phenolic acidic phenolic groups. So these phenolic groups, they are forming salt with lead acetate solution, and they are getting precipitate out. Okay, and we have to filter that precipitate out. The precipitate material consists of naturally occurring tannins, polyphenols. Okay, so that precipitate is of tannin, it's in salt form with the lead acetate solution. To the clear solution, after filtration we will get again clear solution. In that clear solution, we will add now dilute sulfuric acid. Okay, until the precipitation of lead as the lead sulfate is complete. Okay, so we will again from that filtrate we want to remove now lead, what how much amount lead present. So we have to neutralize that lead from that filtrate. Okay, so for to remove that one we have to add acid. The precipitate of lead sulfate is filtered. Lead sulfate will form now after addition of H2SO4. So we will filter that one also. So lead sulfate we will filter off. Again we will get that filtrate, clear filtrate. That clear filtrate we have to collect, and we have to boil that clear filtrate with activated charcoal. And after boiling with activated charcoal, we have to again filter that one, remove activated charcoal, take again that filtrate and concentrate that filtrate to 50 ml. Okay, so here is the concentrate that filtrate to the 50 ml. And now this filtrate, we have to cool that filtrate at room temperature and extract that filtrate with chloroform. Okay, so after extraction of chloroform, we have to collect the chloroform layer, and this chloroform layer we have to dry over sodium sulfate to remove the remaining water molecules from that chloroform. And okay, and this we have to distill that one. Okay, chloroform we have to distill out, and whatever the things remaining in that flask, we have to take out chloroform. Okay, by distillation we have to withdraw that chloroform, and the things remaining in the flask, in that beaker, in that round bottom flask, that thing we have to that residue we have to extract with petroleum ether. Okay, so once we will extract that residue with petroleum ether, at the end we will get our caffeine from that petroleum ether. Okay, so this is the experimental procedure of isolation of the caffeine from the tea leaves. So very simple method. First of all, we have to separate out tannins present in our filtrate of that ex, uh, uh, boiled hot water. We have to separate tannin. Once we will separate tannin, the remaining filtrate contains only caffeine. We can say only caffeine contains. That caffeine we can isolate with the help of H2SO4 and all this. So we have seen one this slide shows that natural form of caffeine more soluble in less polar solvent. That one we will treat with the H2SO4. Okay, so it will form the protonated caffeine, NH, there is formation of salt, and this salt is highly soluble in water, and in this way we can isolate this caffeine. Okay, so different method they do, different people or different laboratories, they do develop their own method of extraction, isolation of caffeine from tea leaves. So whatever procedure I have given, we want to follow that procedure. Here is a little bit information about tannic acid and all. What is the structure and in which different things the tannic acid they are present. Different seeds, barks, how to tannic acid is present. Okay, so like that. So many different groups they do use of they do develop their own methods of isolation of caffeine from the tea leaves. So here is also one more procedure to isolate the caffeine from tea leaves. Extraction, how to do the extraction, it's a little bit theory behind the extraction. Solvent, which solvent we have to choose and all. Salting out effect, why we have to add salt to isolate all these things. Okay, so if once we will form salt, how that one differs, isolation is getting easy. So all these things I have sum up over here. Caffeine, how the caffeine once that one is entered in the human body, how the metabolism of caffeine occurs, and after metabolism what types of compounds they do form in our body. So everything a little bit information I have sum up. So here at bench work, what we have done, we have done some chemical method of analysis of caffeine. We have implemented some chemical extraction technique. So from the caffeine, from the tea extract, from the filtrate of that tea leaves. So that filtrate we can directly analyze with the help of the high performance liquid chromatography. And with the help of high performance liquid chromatography, here you can see this graph we got with detention of time and absorbance of tea extract, okay, green tea extract, HPLC of green tea extract. And here there are some 12 peaks we have observed here, and each and every peak retention time they have given for all peak 1 to 12 peaks we have observed here. Okay, so 12 peaks retention time they have given, and names of each peak, what compounds they do present in green tea extract they have given over here, and how much milligram of concentration of that particular compound present per ml of that green tea extract. That one we can calculate with the help of this high performance liquid chromatography. So different sound techniques, sound sophisticated instruments, so we can go for analysis of so many valuable informations. Okay, so day by day these things getting very well, and we can use them to do different things. So here you can see caffeine, you can find the pick number 7. So here is the 7 number pick, which we got it from the graph of this HPLC. Seventh number peak, quite big peak. This will be a quite sharp peak. Seventh number peak, and retention time is 12.08. And here you can find caffeine. They have spotted caffeine at this here. Okay, at the retention time 12.08. So this type of technique also we can implement, but not at here at MS level. At advanced level we can implement. And result table, whatever you are getting your final product, you can write it down in result table, particulars of the product, whether it's solid, if you got solid you can go melting point, if you got liquid you can write it boiling point, and practical yield you can, all these things you can sum up over here. Okay, so in this way we can do the isolation of the caffeine from the tea leaves.